before that on BBC News, it's time for Talking Business.
Hello and welcome to Talking Business. Here's what's on the programme this week. Digging for influence. Rare earth elements power everything from computer chips to wind turbines. But who controls the buried treasure? The materials are crucial for the global economy, and just one reason why Donald Trump wants control of Greenland. But China is also vying for dominance. I'll discuss that with these two. This professor is a top expert and will explain how access to rare earths is reshaping the global economy and political alliances. And this man is mining one of the world's biggest rare earth deposits in Greenland. He'll tell us who wants to buy it and what it's like to be caught in the middle of one of the hottest issues of global politics. And super fast charging. The boss of a British startup tells us why he's trying to get big vehicles running on electricity, and crucially, how they'll charge quickly enough to avoid that dreaded range anxiety. Wherever you're watching, welcome to the programme. Now this week we're looking at something crucial to the global economy, but chances are you've never even heard of it. Rare earth elements power everything from your smartphone to a jet engine, and so many of the other things that help the modern economy function. It'll be hugely important in the AI and electric vehicle revolution, but also for things like high-tech military weapons as well. They might be called rare elements, but there's no shortage. They're deemed rare because they're often difficult to extract from the earth in usable quantities. But they're also at the centre of a growing political storm. They're one of the reasons Donald Trump wants to buy Greenland, and a key source of tension between China and the rest of the world. They've got exotic-sounding names such as holmium and praseodymium, and there are 17 of them. China's former leader and key economic reformer, Deng Xiaoping, was early to recognise the value of rare earths and their importance for new tech. In 1987, he's widely reported to have said, "The Middle East has oil, China has rare earths." And in the years since, China has built a dominance of the global supply chain. 90% of refined rare earths come from China. And it's in a good position to keep that dominance going. China has the world's biggest reserves by some distance, followed only by Vietnam and Brazil. But the refining process is normally bad for the environment and produces radioactive waste, which is why there's only a handful of facilities to do it outside of China. The West is working to change that, and under Joe Biden's watch, the US set up an alliance with the European Union and 29 other countries to try to reinvent the supply chain.
Without these minerals, we simply cannot function. They can't function. And we expect the demand for them to increase by 400 to 600% over the next several decades.
Well, Donald Trump agrees on the importance of rare earths, and on his first day back at the White House, he signed an executive order pledging to make America the world's leading producer and processor. But he's also looking abroad. Shortly before he was sworn in, he was asked if he could rule out using military or economic coercion to get his way.
I can't assure you, you're talking about Panama and Greenland. No, I can't assure you on either of those two. But I can say this. We need them for economic security.
The European Union also knows rare earths are critical to its future.
We have launched a new generation of trade deals to secure supplies of raw materials, clean energy and clean tech from around the world.
It's actually EU member Denmark that controls Greenland, but the island has a large degree of autonomy and says it's not for sale.
We don't want to be Danes, we don't want to be Americans, we want to be Greenlandic. And of course it's the Greenlandic people who will decide their own future.
So let's get a better understanding of why those materials are so important to the global economy and why politicians are focused on getting hold of them. I've been speaking to a professor of environmental studies and public policy at New York University. He's a former minister in the Greek government and wrote a book called China and the Geopolitics of Rare Earths. Professor Sophia Kalantzakos, welcome to the programme. It's great to have you with us. And there's so much for us to talk about, but explain to me first of all why these rare earths are so valuable. What do they do? What do they provide that powers the global economy?
Well, they're very valuable because for the various tech applications, military applications, renewable applications, you name it, they contain rare earths. You know, we embarked on this green transition for which rare earths have been absolutely indispensable. And that's the electrification of transport and the diversification of our energy mix to include renewables. So we did this to offset the worst of the climate crisis. At the same time, we also thought the fourth industrial revolution, which is the digitalization of the global economy and the introduction of AI, was not only possible, but we felt that this would make our economies less material intensive. But these applications require rare earths, but also insatiable amounts of energy. And I think that is a huge problem. Chips need rare earths. The magnets that go into some of these technologies, they all need rare earths. Rare earths are going to again be central in this transition as well.
Are there enough of them to go around to meet that demand?
At the moment, we have enough rare earths, but as there's this huge economic competition happening, the West has woken up to the fact that China controls the entire supply chains, not only the materials, but also the supply chains from mine to market. The West or China's competitors need to ensure that there's a diversification of the supply chain. There are rare earths in other countries beyond China. They're in Australia, Vietnam, Brazil, but that doesn't mean that these countries will be willing to sell only to the United States, Europe, and its allies.
Why is it that China is so dominant in this field?
Because China recognized, first of all, that rare earths were going to be indispensable. It became a strategic asset for them. It became, when they realized that they need to leapfrog in certain technologies, why is China ahead in EVs? Because it couldn't compete in traditional automotive. It needed to leapfrog. It realized that tech and the electrification of transport and renewables, scaling up renewables, were going to be really important for its economy. And it had an industrial policy. The West relied very much on globalization, on the bottom line, on the fact that China was a very big market. So it was easier for China to consolidate these supply chains because it was a market in China, and everybody wanted to be next to all of the various factories that produce the components that went into the final application.
But China still has that monopoly on refining and processing, doesn't it?
It's true. And look, I think the world is going to have to diversify because, after all, these are industrial plans. We embarked on, in fact, from a climate perspective, the transition to the electrification of transport and the production of renewables, in a sense, is a way to find an industrial policy solution to a problem that industrial civilization created. So we're actually coming out with a new industrial plan that will create jobs, that will create product, that will create economic ties and trade, boost trade, help the developing world move forward, but also the developed world. So refineries, yes, we need to refine them. This requires permitting. It requires, though, also complying to ESG standards. Europe has some of the most advanced standards in order to be able to not, how would I say, rape and pillage what's left of the planet. The idea is to do things in a way that's mindful and environmentally doable because it's not only about emissions.
I know here no one really knows the answer about how this will all play out, but what is your forecast over the next 12 months, 24 months? What does this market look like? Who will be the dominant players, and will it still be such a political issue as it is now?
First of all, there's not going to be a change in the dominant player if we're talking about rare earths in the next few months. Europe has been trying to diversify its supply chain, create, make magnets in the European Union. It's looking to build partnerships with other countries that have the potential to produce rare earths. Let me also say that, we hear a lot about exploration in all these different parts of the world. These projects are either at very early stages or they will take at least 10 years to come online. So not much is going to be changing.
Given the state of relations between the US and China right now, do you expect that China will block American access to its refining, but also to that finished product?
Even the rare earths produced in the United States are being refined in China still. So that's nobody's trying to exclude the United States per se. I think it's a question of what kinds of messages the United States is sending the world. Because up until now, under the Biden administration, the logic was we work with our allies and we compete with our rivals. Now that logic has been tossed out the window. So I it's not at all clear how things will work out. And China will continue to dominate the supply chains from mine to market while others try to also build resilience and diversify. That will not stop.
Professor Sophia Kalantzakos, thank you so much for being on the programme with us this week. Thank you.
Thank you so much for having me.
Well, one company that's found itself right at the centre of these tensions is, aptly enough, called Critical Minerals. It's mining one of the world's largest deposits of rare earths in Greenland, at a time when the country is facing unprecedented global attention. I've been speaking to its chief executive. Tony Sage, welcome to the programme. Now, talk to me about your investment in Greenland. What is it that you're digging out the ground and why is it so important for the global economy?
It's important because no one commodity should be monopolised by any one jurisdiction. And in this case, it happens to be not a friendly jurisdiction to the West, China. China controls 97% of the world's rare earths. Why it's so important we're digging it out of the ground outside of that jurisdiction is because they do control 97% of the world's supply. And you're using it for everything. Electronics, this iPhone that I'm on at the moment, you're using it for missile systems, you're using it for rockets. Elon Musk couldn't send a rocket up into space without that, satellites. So really everything in the modern world comes down to these rare earth metals.
And so you find yourself right now caught in the centre of a huge global row about access to this really valuable stuff that is so vital to the global economy. What is that like?
Look, it's pleasurable in one point because going around trying to raise money for any mineral project is difficult in this climate. A lot of people see mining as a dirty industry, if you like to call it that. We don't see it like that, obviously, in the mining industry because the whole of the Western human civilization now is based on everything that comes out of the earth. So you cannot really progress. If all mining stopped tomorrow, the world would stop in about a month. That's how important mining is. So it's become very, very political in a way because Mr. Trump, now President Trump, about 3.5, 4 years ago, floated the idea, 5 years ago, in fact, floated the idea of buying Greenland. That was after Greg Barnes, who has had this deposit for 20 odd years, went to the White House and explained what was there. And what is there is the largest, outside of China and Russia, it's the largest rare earths deposit in the world. It's 4.7 billion tons. If we mined it starting tomorrow, it would take about 2,000 years to mine everything out, all the rare earths out of it. That's how big the deposit is. And there's not really any other big deposit of rare earths in Western countries. There's some in Australia, there's some in the US. And ironically, the ones in the US ship the rare earths to China to process to get back the rare earth metals, which is obviously not in the interests of the EU, not in the interests of NATO, and not in the interests of the US Defense Department.
What pressure are you getting from places like the White House not to sell this stuff to China?
Look, me personally, I didn't get any pressure, but Greg Barnes, the previous owner, before we bought it off him, was told blank by the Greenland government after pressure from the White House not to sell any of the rare earth to China. So yeah, he was under a lot of pressure. Hence, I think one of the reasons he decided to sell it to us. So that pressure then goes across to me and my shareholders now. We've already been to Washington once. That was pre-Trump coming in, being inaugurated. So we're now being invited back to Washington to visit the various departments that are very interested in it. And there's 3 or 4. The main one, obviously, is Department of Defense. The next one is Department of Energy. So we'll be definitely, and the State Department. So we'll be definitely visiting those over the next month or so.
Do you get a sense from them about what they want to talk to you about and what those conversations will look like?
Yeah, look, they actually want to just secure a supply outside of China and Russia to keep the whole of the supply chain of these rare earth minerals. You've got to then process them into the particular metals that are required for missile systems, for destroyers, for submarines, for F-35 fighters, Elon Musk for his Starlink satellites, etc., etc. So what the Defense Department will do, they don't actually buy these minerals. They just want to make sure the supply chain. So obviously they would introduce us to people like Lockheed Martin, to Raytheon, to Boeing, and companies like that that would turn our product into what the Defense Department, the Department of Energy, SpaceX, Tesla, and those companies will be using, from Apple, even Meta and Google now with their AI industries booming. They need to obviously have superconductors, chips, and the like, and all those are formed from the rare earths that are on our property.
It strikes me you're in a really powerful position, for want of a better word, because you could sort of name your price, couldn't you? That you've got access to this valuable reserve that no one else has. You know, China wants it, and America is saying to you, don't sell it to them, sell it to us. You could pretty much name whatever price you want, couldn't you?
Look, the interesting thing about mining is other people find when things become this rare that people find it. Like 8 years ago, no one really was mining lithium, and the lithium price went to $7,000 a ton. When it does that, all the other explorers go out and find lithium, and it's come back down to $1,000 a ton. The same thing will happen with rare earths. So we're under no illusions that we're in a powerful position. We're in a very good position to seek a subsidy. For example, rare earths is that important. The Australian government has never done this before. They gave $1 billion to an Australian company to enhance their rare earths deposit in Western Australia. The US government under Biden had $1.5 billion earmarked for rare earths projects in the West, mainly the United States. There's 2 or 3 up and coming ones there. The advantage for us, ours has been drilled. We know where it is. It's relatively cheap to extract. It's very environmentally friendly. So yeah, we've been very lucky in that way where we are. A lot of these rare earths are in areas which could be fragile, especially the ones in the United States.
As you say, getting the stuff out of the ground in Greenland is a bit easier than maybe elsewhere. But there is still a huge logistical and environmental challenge when it comes to refining this into useful stuff, isn't there?
Correct. That is the biggest challenge that we face. The mine itself will be sustainable. We have 2 byproducts that are building materials, which will make the mine profitable. We hope to start mining late next year. We've got already our environmental approval and our mining license to mine 500,000 tonnes per annum. So we'll start that process as quickly as we can, and we'll get those 2 building materials and we'll ship those to Iceland or to Europe. And that will make the mine break even. The rare earth part of the equation is going to be a negotiation. There's 3 or 4 technologies in the West. There's 1 Norwegian, and there's 2 out of the US. So we'll be taking another few bulk samples of our ore to the 3 laboratories and just see which one and which process is going to be the best and easiest way to process it. Now, whether that's processed in an EU jurisdiction or a US jurisdiction is up to where we get some funding from. We're happy with either because it's going to go service the West. So it's not going back into China or Russia.
And Tony, what toll does this take on you? I can't imagine you got into this job imagining you'd be at the centre of a global storm. What pressure does it put on you?
Yeah, well, look, it does. It's midnight. I'm talking to you. I just want to get our story across so people just don't see us as a greedy mining company taking advantage. You know, it's something you do when you take on a role. You take on all avenues. I didn't expect it to be this political. I didn't expect Mr. Trump to go this hard in the press on Greenland itself. I didn't expect him to have a conversation with the Denmark Prime Minister so quickly. My gut feeling, being on the ground for 3 years, the local population do not want to be part of Denmark. They want an independence. They don't want to be part of the US either. I think they'll try and force a referendum. The Danes will have to accept it. and then they probably will do a deal with the US separately, but not become a territory or a state. They're very fiercely independent.
Tony Sage, so good to talk to you on the programme this week. Really fascinating to get that insight. Thank you.
No problem. Thanks very much.
So, we know that rare earth elements are crucial to the global economy, and that's especially true for the production of electric vehicles. China currently produces more than 3/4 of all EV batteries and nearly 2/3 of all EVs. But whilst the technology now allows smaller cars to go further and charge more quickly, larger industrial vehicles still rely on fossil fuels like petrol and diesel. Trucks, buses, coaches and construction vehicles would need batteries that are too big, too heavy and too costly. But one UK firm says it has the answer, and I've been speaking to its chief executive. Jean de la Verpillière, welcome to Talking Business. It's so good to have you here. And talk to me first of all, if you will, about what it is you do, because you're trying to solve a big problem for the EV industry, aren't you? About making bigger vehicles be powered by electricity. Just explain that.
So, as you know, there's a general trend towards electrification. Started with consumer electronics, evolved into passenger cars, and we see Tesla and other brands at the forefront of this. What we are doing is really addressing what we see as the next wave of this movement, which is the electrification of heavy-duty vehicles. So we are talking trucks, buses, trains, ships, and the likes, which are more difficult to electrify. And we, Echion Technologies, are a spin-out of the University of Cambridge and have developed technologies to address precisely this.
Why are they more difficult to power with electricity?
These heavy-duty vehicles are, by definition, bigger. They require bigger batteries, and they're used in a different way than electric cars. They're used typically very intensively. So sometimes, 22, 23, 24 hours a day. They are used in industrial and commercial settings where you cannot afford to have your vehicle sitting idle, doing nothing, being recharged, for instance, because that costs money. Sometimes to operate in very difficult environment, very cold environment, hot environments. All of these things are just very difficult for the battery. So what we are doing really is addressing the very difficult limitations that very difficult requirements that these applications place on batteries.
Whenever we talk about EVs, the first thing that a lot of people will talk about is that range anxiety, worrying that the battery will run out before they get where they need to get to. Especially true, of course, if you're talking about long-distance lorry drivers. The demands that they are putting on this technology will be huge. How do you solve that?
So our approach is to say, well, actually, you don't need a gigantic battery that will last for a very long time. Instead, go with a smaller battery that, will carry less energy, but you'll be able to recharge this battery very fast, maybe in 5 or 10 minutes, which means that actually you don't care about the range. All you care about is getting to your next charge point. And by doing that, then all of a sudden, you don't need to have a battery that weighs multiple tons, that accounts for more than 50% of the cost of the vehicle. You can do with a smaller battery that is just the right size for what you're trying to do, and you recharge it more. And we believe that economically more sustainable in many cases. What the user wants is, we're really targeting a recharge time that is under 10 minutes.
In this program, we're talking a lot about the sort of geopolitical war that's going on right now, about access to things like rare earths and rare minerals that are used in things like batteries or mobile phones or other bits of tech, particularly things like computer chips. Are you confident that the world has enough of this stuff to create the batteries that you quite clearly need for your business?
The answer is it's not. So the technology that Echion is using in particular relies on a mineral called niobium, which may sound like a scary rare element, but that is actually not. It's as abundant as lead, for instance, in the earth crust. The question is more about, can people mine it in a way that makes sense environmentally, but also economically, of course, so that it gets to the end applications? These are definitely good questions that I think need to be considered at the very beginning of any technology choice.
Is there a full circle moment here as well? Because I know you've got trials currently going on with mining firms in Australia using your technology. So the firms that could be digging this stuff out of the ground actually could be powered by the stuff that they're digging out.
Yeah, no, that's a very interesting use case. One application in the heavy-duty vehicle space that is getting a lot of attention at the moment is the electrification of mining vehicles. So these are, typically very, very large trucks. 300-ton trucks, the size of a house. They're gigantic. They burn incredible quantities of diesel fuel at the moment. Thousands of liters per day. So there's a real motivation to electrify them, not only from an environmental point of view, but actually also from an economical point of view. It's not something that standard battery technology, standard battery chemistries can do well. We believe we have the solution to this problem, and that's why we're pushing XNO, our technology, into these applications.
What is the challenge that you face in the industry that you still don't have the answer to yet? What still eludes you?
It's the interface of three aspects. It's the aspect of what the technology does and can you prove it? It's the aspect of does it all make sense financially? And then there's a question of mindset, and are people ready to accept change and ready to make bets and take risks to get there?
Jean de la Verpillière, thank you so much. Really good to talk to you on the programme this week. Thanks for being with us.
My pleasure. Thank you.
That's all for this week. You can keep up with the latest on the global economy on the BBC News website and the smartphone app. But for this week, that's all. We'll see you very soon. Bye-bye.
Hello there. A rather grotty day for many of us